China versus Japan. Who will win the race to build a space elevator until 2050? Is this really possible? How would this construction go, and what material to use to do something so great? When historians look at this period 500 years from now, they will notice a turning point exactly at the moment when we built the space elevator. This represents the pre-space and the post-space. It is the emergence of a completely new society where everything changes. Imagine simply going up a cable to space. Without rockets, just press the button to go up. And that's it. You'll be up there watching our beautiful blue planet. The concept is known as space elevator. It could not only change the way we leave the planet Earth, but it could also completely transform the relationship of humanity with space. Space elevators are one of those technologies that sci-fi fans like me and you love. This idea in particular is on the frontier that could cross the division between fiction and reality. This, of course, if somehow we improve the existing technologies. After all, necessity is the mother of invention. In this video, we will explore what is most advanced so far and find out which countries and companies that keep this idea alive. Let's tell everything from now on. So let's get started. Concepts of a device similar to a space elevator have origins in the 19th century. Both Russian and American scientists have elaborated several theories about a structure that would depart from the surface of the Earth towards space. But it was only in 1979 that this concept gained greater visibility when the writer Arthur Clarke presented it to the public in his book, The Sources of Paradise. The idea of a space elevator may seem like something out of a science fiction book, right? However, what if I told you that a company in Japan promised to make it a reality? Imagine pressing the up button on the elevator, and as it starts to go up, you realize that you are not going to the top of a building, you are going straight into space. Is this really possible? The answer is yes, thanks to centrifugal force. Imagine the ball spinning around a pole with a certain angular velocity. The rope will be straight and tense against the pole because the centrifugal force pulls it out. The big problem is the tied ball winding around the pole. This happens if the rope is not tensioned enough to rotate around the center of rotation, the pole itself. It will simply wind around it. Scientists and engineers are trying to recreate this dynamic, but on an astronomical scale. And to do this, you need to work with the natural rotation of the Earth. Therefore, the structure will need to be located on the equator. Let's imagine a base located in the middle of the Atlantic Ocean. From here, we will draw a straight line towards space. For now, it is just a line, no existing structure. However, any structure that is built will need to be along this line. If it is not in sync with the Earth's rotation, the structure will bend and break. Our orbit needs to be circular instead of elliptical, since the elliptical orbit requires a cable capable of constantly changing in length without breaking. We can find a circular orbit that meets these ideal conditions with simple mathematics. To remain in a stable circular orbit, we need the centrifugal force to be equal to the gravitational force. We come to this with all these complicated mathematical calculations, which are not worth explaining because we would waste a lot of time. Solving all these calculations, we should be at least at a geostationary orbit, about 36,000 kilometers above the surface of the planet from a point on the equator. Now let's imagine that we have the cable, and let's start a construction process. Building from the planet is not an option. We need to build from top to bottom. And this is where things get complicated. If we extend the cable directly to Earth, we will move our center of mass and interrupt our orbit, removing the station, the ship, or whatever we will use as an anchor. To avoid this, we need to extend our cable in both directions. This keeps our center of mass in the desired circular orbit. If we put a counterweight on the end, we do not need to have equal lengths of the cable stretching on both sides to balance our station. This counterweight could be, I don't know, a useful platform for future operations or something like that. This counterweight creates a tension in our cable, which will reach the maximum tension in our neutral point in the geostationary orbit, since everything below it is pulling towards Earth and everything above it is pulling into space. Such a cable must be made with a resistance at least 240 times the maximum resistance to the traction of the steel. So steel can already be discarded as raw material for the construction of such a cable. Although we do not have a completely developed solution, there are several potential materials that can be used. Among them, the most promising are the carbon nanotubes, known for their incredible resistance and lightness. They have already demonstrated their potential in various areas, such as the aerospace industry itself. Another option is graphene, a material still in the study and exploration phase for possible applications. However, its great weak point is still its production in large quantities. It is quite plausible that a relevant discovery may occur soon, as advances in science continue to expand the range of possibilities every day. According to the engineering palette, studies are advancing in calculus. It is already believed that a cone-shaped structure may be the solution to use one or a combination of less resistant materials. In 2018, scientists from the University of Shizuoka, in partnership with Obayashi Corporation, successfully tested a mini space elevator project. The load was taken to the ISS, aboard the H-2B rocket. They launched the prototype with two extremely small CubeSats connected to a 10-meter cable. The cable remained stretched and did not break during the experiment. After this success, two space elevator projects were proposed, which are currently being explored by the Japanese. Already on the side of China, the Chinese Academy of Technology says that it has already started this space elevator project and aims to complete it by 2045. Well, no images or documents have been released. As you know, everything in China is done under the covers. Or are they just talking from mouth to mouth? Currently, they are developing reusable suborbital rockets necessary for elevator construction. We even have a video here on the channel about these rockets. It will be here on the card. Returning to Japan, the Obayashi Corporation project should be completed by 2050. Interestingly, their concept of construction is a project based on the engineering work of the creators of the only tallest independent block tower in the world, the Tokyo Skytree. This is, in fact, a very crazy idea. The company plans to carry out the construction in several stages. First, an ISS-style low Earth orbit station will be built, but smaller. It will be moved by electric power so that it can enter geostationary orbit. From this point on, it will be divided into two. One of the parts goes into deep space, while the other remains in stationary orbit. Simultaneously, the cables are stretched. What goes down towards Earth will be carried by small propellers. It is estimated that this process can take up to 8 months until the cable reaches the surface of our planet. In total, the cable will have 96,000 kilometers of extension, in addition to intermediate stations along the cable. The big question we should ask Kobayashi Corporation is where they are going to get material to make 96,000 kilometers of cable. As I mentioned, the most promising material today is carbon nanotubes. Research done in Chinese laboratories indicates that a cubic centimeter of this material can support up to 800 tons. Like graphene, its problem is mass production, and the largest carbon nanotube was made in mid-2018-2019 with 70 centimeters, and since then, the manufacturing process has been evolving. It is estimated that today it is in the house of $1 per gram to have it in its raw format. Perhaps Kobayashi Corporation may be betting that by 2050, the manufacture of carbon nanotubes will be as simple as the manufacture of steel today. In addition to this, There are other problems, such as resisting climate change in the atmosphere, corrosion, debris reaching the structure, and a source of energy to power the elevator. But maybe these are the smallest of the problems. As we explore new technologies, the construction of space elevators emerges as a possible feat that will shape the future of space exploration. Facing incredible challenges and demanding an effort never seen before, these revolutionary structures promise to make space more accessible and sustainable for the next generations. And this journey inspires curious minds and fearless hearts of scientists and engineers to challenge the limits of space, leading us to new, exciting discoveries. The future is as vast as the universe, and with vision and effort, nothing is impossible. Space is out there waiting for us, and we are ready to reach it in every way possible. Let's continue our chat here in the comments. Do you think this will ever get out of hand? Will the space elevator be an eternal science fiction? Let me know your thoughts. If you liked this video, we would be happy if you could like it and share the video on your social networks and subscribe to the channel. We have always appreciated your support. Now let's get ready for the next video here on our Wikipedia Plus channel. We'll be back soon. A big hug, and until then, bye.